Welcome to The Explainer. Today we are diving into the really fascinating and honestly sometimes kind of scary world of AI coding assistants.
We sure are. We're going to walk through 6 new research papers that look at what these AI agents can actually do, the very real security risks they're creating, and some of the clever ways researchers are trying to make them better and safer.
And that's the million-dollar question, right? Everyone's seen an AI whip up a simple function in seconds. But what happens when you ask it to take on a messy, complex, real-world engineering task? That's what we're here to figure out.
We've laid this out as a 3-part story. First, we'll look at the incredible new things AI coders are capable of. Then, we'll get into the serious, and I mean serious consequences that come with that power. And finally, we'll see how the AI brains themselves are being fine-tuned for the future.
Okay, let's get right into it. Our first section is all about the new and much more complex jobs we're handing over to AI. We're talking way beyond just finishing a line of code for you. A perfect example of this comes from a paper on a framework called RePro. It's designed to solve a huge problem in computer networking research, which is that less than half the papers in top conferences ever release their code. That makes it incredibly hard to actually build on their work. Wait, so RePro is an AI that reads the research paper and then just writes the code from scratch? That's the gist of it, yeah. It's a semi-automated process, but it uses this really structured pipeline to turn the text of a paper into a functioning system.
So this is how it works. The framework breaks the whole problem down into these manageable chunks. The AI first reads the paper and pulls out the system's architecture. Then, using this technique called structured chain of thought, which is kind of like forcing the AI to show its work, it generates a basic code skeleton. After that, it fills in the details, the actual functions, and finally, it uses a feedback loop to find and squash bugs.
Wow, so it's like an AI assembly line for turning research into reality. That sounds incredibly complicated. And I'm guessing that's not the only really hard task we're giving these AIs. I saw another paper about a benchmark called FeatBench, which tests an AI's ability to do something a lot of developers are already trying to do: add a brand new feature into a huge existing code base. They have a great name for it: vibe coding.
Vibe coding is such a perfect term for it, isn't it? Because you're not giving the AI a detailed, technical spec. You're just giving it a vibe, a user request, like, hey, I want to be able to exclude certain files when I unzip an archive. The AI then has to go figure out which files to change and exactly how to change them.
So how well does that actually work in the real world?
Well, it's a bit of a mixed bag, and this is really where we start to see the cracks. The FeatBench paper shows pretty clearly that an agent's success is directly tied to the project's complexity. Or, to put it more simply, the bigger and messier the project gets, the more the AI just kind of falls apart.
And the drop-off is just steep. I mean, look at this. The best models out there do pretty well on small projects, right? About a 65% success rate. But that number absolutely plummets to just 15% on large repositories. Just trying to navigate these huge, tangled code bases is a massive barrier for the agents we have today.
Okay, so that leads us right into our next section, which is a big one. We've got these super capable AIs taking on huge tasks, but all of that speed and power can introduce some absolutely massive risks.
Exactly. And the first big risk is that the AI generates code that works, but it's dangerously insecure. There's a new benchmark called Secure Agent Bench that was built to test this exact problem. It gives the AI agents these realistic coding tasks, where human developers, in the past, actually introduced a security flaw.
Oh, interesting. So it's basically checking to see if the AI makes the same kind of mistakes that humans did?
Yep, and the results are pretty sobering. For the best agent they tested, only about 15% of its solutions were both correct and secure. Almost half the time, its correct code brought back the exact same vulnerability humans had introduced. And what's even worse, in a lot of cases, it actually introduced brand new security risks that weren't even there to begin with.
That is terrifying. So the code works, but it's basically a ticking time bomb. But there's an even more direct threat that was explored, right? Where the AI agent itself is the one that gets compromised.
That's the second major risk, and it's explored in a paper about a framework called AI Shelljack. It shows how attackers can use something called prompt injection to literally hijack AI coding editors. And the attack is hidden in plain sight, inside the project's configuration files that the AI is built to read.
So you're saying a developer who's just trying to, say, format their code could have their AI assistant tricked into running malicious commands on their machine?
Precisely. The attacker cleverly frames the malicious command as just a necessary technical step. And since the agent has access to the terminal to run tools like formatters, it just executes the command, no questions asked, without the developer ever knowing. Yikes. And how often do these attacks actually work?
The success rates are just alarmingly high. I mean, the researchers tested dozens of different attack techniques from the standard MITRE ATTCK framework. And things like initial access or discovery, where the AI is tricked into exploring the system or even creating backdoors, those succeeded over 90% of the time. The agent basically becomes a malicious insider on your computer.
Okay, this is a pretty bleak picture you're painting, Theo. We have these tools that are super powerful but deeply flawed, and they're also vulnerable to being hijacked. So, for our final section, how on earth do we fix this?
Right. Well, a big part of the answer is actually in how we train them in the first place. A lot of the training data for these big models is synthetic, meaning it's just generated by other AIs. There's a key step called verification, where you use tests to filter out all the bad code. But a recent paper shows that our human intuition about how to do that can be completely wrong.
Wait, what do you mean? You're saying being more strict about what code passes isn't always better?
Exactly. You would think that only training the AI on code that passes 100% of its tests would give you the best model. But what the researchers found is that this actually filters out too many useful, creative, and diverse examples.
So, and this is the crucial point, a more calibrated approach actually works better. By relaxing that threshold just a bit and accepting solutions that pass, say, 80% of the tests, you actually end up training a more robust and more capable model. It's about finding useful signals in the data, not just demanding perfect scores.
Okay, that's a much smarter way to train them, but smarter training is one thing. What about making them safer in real time? I have to imagine that having an AI constantly checking for security issues could be really slow.
Oh, it is. It's a huge bottleneck. A paper on a method called PSRT tackles this problem head-on. You see, a lot of safety systems use what's called a guard model to check for harmful queries. These are usually large reasoning models, or LLMs, that have to think out loud token by token to reason about whether a request is safe. It's effective, but it adds a ton of delay.
So what does PSRT do to speed that up?
It does something really clever. It replaces that entire long chain of reasoning with a single pre-learned shortcut, what they call a pre-filled safe reasoning trace. You can really just think of it like a cheat sheet. The model learns the essence of the safety reasoning, so it doesn't have to perform the whole song and dance every single time.
Whoa, so it just jumps straight to the answer. That has to be a lot faster.
It is a massive difference. PSRT cuts down the number of generated tokens by over 200 on average for these models. It basically eliminates the reasoning overhead completely, which makes real-time safety checks way more practical. And it does all this with a tiny, almost negligible drop in accuracy.
So let's wrap this all up. AI coding assistants have clearly gone from being a neat little novelty to a seriously powerful engineering tool. But that huge leap forward has also exposed some major flaws, both in the code they write and in their own security.
The good news in all this is that the research is moving just as fast. We're starting to see a shift away from just chasing raw capability and toward carefully calibrating these models to be more robust, more secure, and more efficient, right from the ground up.
And that is the perfect question to end on. Thanks for listening to The Explainer.
Thanks, everyone.